Okay, this is day 4 of Unit 8. We started with a little ticket quiz today, so if you were absent, you'll need to make that up. And then we did this warm-up. Actually, we took quite a bit of class time today to work on the warm-up. So, pause the video, take probably several minutes to complete the warm-up, and then play to check your answers. Okay, so I'm going to get started here with letter A. So I'm supposed to put this in summation or sigma notation, so I know I need a sigma, and remember I told you always start with n equals 1 when you're writing sigma notation. So now I need to figure out two things: the equation, the explicit equation to put beside the sigma, and how many terms to put as the upper index. Now remember, the upper index is not necessarily always the number of terms, but it is when we start with n equals 1 being the lower index. So the upper index will be the number of terms in this particular problem. And really, in any problem where you're putting it in sigma notation, you'll always start at 1, so then the upper index will be just the number of terms. So I'll figure out the number of terms here in a moment, but before I do that, I'm just going to first look at the sequence, the series, and determine what kind of sequence the series is based on. So -2, 4, 4 to 10, 10 to 16, I can see it's arithmetic and the d value is 6. So I know that the arithmetic explicit formula is a sub n equals a sub 1, so -2, plus d, which we just said was 6, times the quantity n minus 1. And remember, we don't use the a sub n equals in the front of that. Now, I don't want to leave it that way. I want to simplify. So let me rewrite my sigma, my n equals 1. And when I distribute the 6, I'm getting 6n minus 6. And when I combine that -6 with -2, I'm getting -8. So 6n minus 8 is the equation that we will have beside the sigma. Now, the only thing I also have to figure out is how many terms are in this series. So I'm going to set 196 equal to the explicit formula. And I might as well use the simplified form that I've already gotten. I don't need to go back to the original. So I'm just going to set 196 equal to 6n minus 8. And I'm going to add 8 to both sides. And I'm going to get, 204. That's a 196, right? 196 plus 8. Yeah, 204. And then I'm going to divide that by 6. And I'm getting 204 divided by 6, I think that's 34, but let's check that. Yeah, 34. Okay, so we're getting 34 terms. So if there's 34 terms in the series and we started the lower index at 1, that means 34 is what we put as the upper index. So that is our answer for letter A. Okay, letter B. So once again, I first have to figure out if it's arithmetic or geometric, and I'm seeing 3, 3.5, 4. That looks arithmetic to me. We're adding a half each time. So I'm going to figure out what the explicit formula would be for this series. So I have a sub n equals a sub 1, which is 3, plus 0.5 is the d, times the quantity n minus 1. So a sub n equals 3 plus 0.5 n minus 0.5. So then I'm going to combine the 3 and the negative 0.5 to get 0.5 n plus 2.5. So again, not including the a sub n equals, I'm going to go ahead and write my sigma and 0.5 n plus 2.5. Lower index, we're going to make 1. And upper index is number of terms. Well, I see plus dot 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 here, so I know that that means this series is continuing on forever to infinity. So my upper index is infinity. And that is sigma notation for letter B. Okay, C. Let's see, I guess I'll put C here. So for C, -2, -6, -18, it looks like this is geometric and the R value is 3. So I'm going to go ahead and write my sigma and n equals 1. And my explicit formula for a geometric series or sequence is -2, times the r value, which is 3, raised to the n minus 1. And the upper index is the number of terms. Well, when I have such a short series just written out here, I can literally just count 1, 2, 3, 4, 5, 6 terms. So because I started at n equals 1, the upper index is 6. And that's my sigma notation for letter C. Okay. Number 2. So number 2 says evaluate 1A using the appropriate formula. Well, hopefully you noticed in last night's homework there were 3 different sets of directions. So we had either rewrite in summation notation, which is what we just did. We took the series and we turned them into summation notation or sigma notation. Also, some of the problems in the homework asked you to rewrite the series as a sum. In those cases, you were given sigma notation, and what you were supposed to do was write out each one of the terms with plus signs in between, but not actually evaluate the sum. Just rewrite the series as a sum. Rewrite all of the terms out with plus signs. The third set of directions in the homework and here in this warm-up is to evaluate. Remember that evaluate means tell me what the sum equals. Okay, so I don't want you to just write out the series. I actually want to know if I added all those terms together, what the sum would be. So that's what evaluate means. So we're going to do that right now. So evaluate 1A, okay, well, we're going to go back up. Well, we already said that we already recognized that this was an arithmetic series. That's why we use the explicit arithmetic formula. So it's arithmetic, which means I'm going to use the finite arithmetic sum formula. Why finite? Because it has a beginning and an end. It doesn't say plus dot dot dot. So with that formula, if you remember Gauss, the story with Gauss, S sub n is equal to n divided by 2 times the first term, which is a sub 1, plus the last term, which is a sub n. And that is the sum formula for the finite sum formula for an arithmetic series. So I'm going to substitute in what I know here. Well, we already used the explicit formula to determine that there are 34 terms. So S sub 34 is equal to 34 divided by 2 times the first term, which was -2 in this series, plus the last term, which is 196. So that gives me 17 times 194. And let's see if I have that written down here. $3,298 is the sum of those 34 terms. Okay, so that takes care of number 2. Number 3. In number 3, we know it's arithmetic. We know that the first term is 128. We know that the sum is -3,952. And lastly, we know that there are 52 terms. So we're going to go ahead and figure out which formula we can use, what we can plug into. Well, there's 2 different things we could use here. We could either use the arithmetic explicit formula or the arithmetic finite sum formula. Well, if you think about the arithmetic explicit, I don't know enough information yet because I don't know D and I don't know A52. I know S sub 52, but I don't know A sub 52. So I can't really get too far if I try to use the arithmetic explicit. So instead, I'm going to look at the finite sum formula for an arithmetic series, which again, we have written right here. So S sub n equals n divided by 2 times the quantity A sub 1 plus A sub n. So S sub n, that's S sub 52. So that equals n divided by 2. Well, n is 52. A sub 1 is 128, plus sign. A sub n, that's A sub 52. That I don't know. But I do know S sub 52, so I'm going to next substitute that in. So 52 divided by 2 is 26 times 128 plus A sub 52. So I'm going to now solve this because I have everything I need except for I have everything I need to figure out what the 52nd term is. So I'm going to divide by 26, and that is going to give me, let's see, a sub 52 is, I guess I'll have to grab a calculator here because I don't remember what. Okay, so I found that. So this gives me, when I divide by 26, I'm getting 128 plus a sub 52 is equal to negative 1. Actually, I don't know what that is. I, for some reason, don't have that. So you'll have to figure out what that is. I don't have a calculator handy. So I'm just going to leave it as negative 3,952 divided by 26. So next, then, I'm going to subtract 128. And when I do that, I'm getting a sub 52, which is, I do have that, negative 152. Okay, now that's not my answer. That's not what I was looking for, but that's going to help me get my answer. So let me extend this a little bit here. So now what we are going to do is we're going to go to our explicit, because remember when I first said about the explicit, I said, well, I don't know the 52nd term and I don't know the d value. Well, now I know the 52nd term, so I can substitute that in and that will help me get the d value, which will then help me get the 20th term. So that's our plan. So a sub 52 is equal to a sub 1, which is 128, plus d I don't know times 52 minus 1 because it's the 52nd term, and a 52 we just got is negative 152. So negative 152 is 128 plus 51 times d. So I'm going to subtract 128, and 51d is equal to negative 152 minus 128, which is negative 408. So then I'm going to divide both sides by 51, and I'm getting my d value, which is negative 8. And we're close. Okay, we're almost there. So now we're ready to get the 20th term. The 20th term, again, I'm going to use the arithmetic explicit, is the first term, 128, plus the d value, which is negative 8, times the quantity n minus 1, and n is 20. So a sub 20 is 128 minus 8 times 19. And that's 128 minus 152. And that is negative 24. Yay, we got it. That is the 20th term. So sometimes you have to take what you're given, and what you're given won't help you necessarily get what you're looking for, but then it'll help you one step closer to what you're looking for. And actually, this was 2 steps closer. So I had to take what I was given, which again, I didn't use the arithmetic explicit because I didn't have enough information to fill in, but I was able to use the finite arithmetic sum formula because I knew everything except for one item. So that one item I solved for, that one item then I could plug into the explicit to help me get the one item that I needed, which was the d. And then once I knew the d and the first term, I could then come up with the 20th term, which is what I was looking for, using the arithmetic explicit again. Okay, so we got through that warm up. Took us a while, but I knew that that would take us a while. So that's why I only have one problem that was an example for today. So we want to evaluate, which again, as I said in the warm up, means we want to say what the sum would be. And hopefully in the homework, you did realize that there were 3 different types of series in the homework problems. We had some that were arithmetic series, some that were geometric, and some that were neither. You should at this point hopefully know, just by looking at a series in sigma notation, you should know what kind of series it is. Here's what I mean by that. When the equation is linear, then the sequence or series, the series but based on the sequence, should be arithmetic. When the equation has a variable exponent, when it's exponential, then the series is a geometric series. And when the equation is anything besides linear or exponential, then it's going to be a neither series. So looking at this, I see this is a linear equation. I'm pretty certain that it's going to be arithmetic. It is arithmetic, but I'm going to just get a couple terms to confirm that to myself, and also to get some practice with rewriting the series. So I'm going to substitute 15 in for n to get the first term. And then I'm going to add, because of the sigma, I'm going to substitute the second, I'm going to substitute 16 in to get the second term. And I'll do one more, 17 in. And then I'm going to simplify those. And I'm just going to put plus, dot, 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 and plus. So this is going to give me 30 minus 5, 25. Plus 32 minus 5 is 27. Plus 34 minus 5 is 29. Now, I am seeing 25, 27, 29. Of course, this is an arithmetic series, so I was right. So because it's arithmetic, I can go to my finite arithmetic sum formula, and then I don't necessarily need to find all of the other terms, okay? Because it doesn't say that I have to rewrite the series as a sum this time. It just says evaluate, meaning just tell me what the sum is. So I know I'm going to use this formula, and this formula requires a couple things of me. It requires me, first of all, to know how many terms there are. So I need to figure that out. Now, be careful. Do not just look at the upper index and say 47. There are not 47 terms. So remember, we have to, first of all, that the upper index is only the number of terms when the lower index is 1, which it's not here. So instead, what we have to do to find the number of terms is, we talked about this yesterday, we're going to subtract 47 minus 15, the upper index minus the lower index, and then we're going to add 1. So when I subtract 47 minus 15, I'm getting 47, that looks like a 9. 47 minus 15, I'm getting 32. And then I add 1 and I get 33. So there are 33 terms, which means S sub 33 is 33 divided by 2 times the quantity of A sub 1, which is the first term. I already know that it's 25, plus the last term I don't know yet, but I'm going to figure that out now. So hopefully you remember from yesterday, to get the last term, I'm going to substitute the upper index into the equation. So 2 times 47 minus 5 is going to give me 89. Okay. And now I can put 89 in my finite sum formula. So S sub 33, the sum of those 33 terms, is 16 and a half, is 33 halves, times 25 plus 89 is 114. And when I multiply 16 and a half times 114, I get 1,881. That is the sum of those 33 terms. Okay. And that's it for today. So your assignment for tonight is right here. So do worksheets 3 and 4, those particular problems. And remember, hopefully you have kept on top of your assignments, stay on top of things. Make sure you know the 4 formulas that we have discussed so far. So we had 2 arithmetic, 2 geometric, and the finite arithmetic sum formula. Those you should know without having to look them up.